Hi everyone, ready for our next lesson, I hope. 6.8 is called Trig Applications. Like yesterday, we're going to be solving missing parts of a triangle, and we're going to be just using the main three SOHCAHTOA, sine, cosine, tangent, but we are going to be applying them in word problems. Now, there's some notes up here. I will admit I did not type all these up. I'm more of someone to just sort of handwrite notes as I go. So yeah, I got these from somewhere else. But there's a few keywords in here that you need to know about. If you are on the ground looking upward at something, the angle that's created there is called an angle of elevation. So that's going to come up in some of these word problems. If you are at the top looking down at something, then the word that is used is angle of depression. But usually in that scenario, the triangle is down here, and the angle of depression is actually not in the triangle. So you have to know something, well, from geometry. I'm not going to give you a long lecture on it, but there was something about parallel lines cut by a transversal, and you have alternate interior angles that turn out being equal. So if you remember that, great. If not, here's what you're supposed to know. The angle of elevation equals the angle of depression. So if we had a scenario like this, you're at the top of a lighthouse, you look down at a ship out in the ocean, and the angle of depression is 35 degrees, then that means that this angle would also be 35 degrees in your triangle diagram. So that's just something there for you to know as we go into this. I am going to, as usual, do the evens. You're going to do the odds. Please do include something of a sketch. It does not have to be super detailed, but you should at least draw a triangle at some point. Show whatever work you can show. A lot of the work is going to be done on calculator. If you handled yesterday's work okay, then this is going to hopefully go okay as well. This is not the sort of thing where you probably have to watch every example. I'm going to do all of these evens just so you got a wide variety of problems to look at. I do want to point something out before I get going, though. In my examples, so problem 2, how far, the first, finding a distance. Number 4, how far, we're finding a distance. Number 6, what angle. So number 6, we're going to find an angle instead of a distance. And then here, how tall, so that's a distance. How far, that's a distance. How far. So in my examples, I'm only going to do one problem where we're going to find an angle. When you go to do your assignment, this one says what angle, so you're going to find. This one, what angle. And this one is what angle. So the odds and the evens don't really align that well like they do normally when I create a lesson. I kind of borrowed this one. We won't say plagiarize, but yeah, I borrowed it for sure. But if you follow through my examples, if you did okay on yesterday's assignment, you really shouldn't have trouble. Of course, if you do have trouble, reach out to me. I will explain, do whatever I need to do to help you out, either one-on-one in a Zoom or in a group meeting or whatever. And then the answer key is down here below. We'll use that as we need to. All right, let's get going. So Matt is standing on top of a cliff 305 feet above a lake. The measure of angle of depression to a boat on the lake is 42 degrees. How far is the boat from the base of the cliff? So here's the cliff. Oops, should be straight up and down. Come on now. There we go. Here is the water. Perfectly flat, calm water. The end is where the boat is. The top up here is where Matt is. When he's looking at it, that's a triangle, right? Every problem is going to come back to a triangle. So our cliff is 305 feet tall. The measurement of the angle of depression. Now the angle of depression is right here, which is 42 degrees. But for our triangle, we can put it right here. So that was what I was talking about up here. And the question is, how far is the boat from the base of the cliff? That would be this distance. Boat to base of the cliff, not the distance from the boat to Matt. Now, you could have a question where they ask you for this measurement. In fact, I think you do in one of your homework problems, but not this problem. We're trying to find the distance to the base of the cliff. So what we've got is a right triangle, obviously. we've got an opposite side and an adjacent side. Opposite adjacent tells me that I need to use tangent. Tangent of theta equals opposite over adjacent. So plug in the numbers. Tangent of 42 equals opposite, which is 305, over adjacent, which is x. To solve this, I need to multiply both sides by x. So I get x tan 42 equals 305. Divide both sides by tan 42. X equals whatever that is. And, of course, I'm going to use a calculator. All these problems, measurements are in degrees, so I got to make sure, hit the little wrench, that I am in degree mode. Good to go. 305, nope, 05 over tangent of 42, and I get 338.74. I believe the directions say round to the nearest hundredth. Hundredth, that means 2 decimal places. So 338.74 feet should be my answer, and there it is. So you get the idea how this is going to go? So if you're good at reading, drawing the triangle, plugging things in, yesterday's assignment went well, you could probably just get straight to work on this. If you feel like you need to see a few examples, that way when you go to do your work, you got some good examples to look at, then by all means keep watching the video. All right, number 4. A ladder that is 20 feet tall is leaning against the side of a building. So here's the ground, here's a building, here's a ladder leaning up against the building. So that makes a right triangle, right? The ladder is 20 feet long. If the angle formed between the ladder and the ground is 75 degrees, so that's 75 degrees, how far is the bottom of the ladder from the base of the building? So we're looking for this distance right here. Call that x. So what do we have in this problem? We've got a hypotenuse and we've got an adjacent. Adjacent and hypotenuse is cosine. Cosine of theta equals adjacent over hypotenuse. So cosine of 75 degrees equals x over 20. To solve this, we're going to have to multiply both sides by 20 to cancel that out. And x will equal whatever that works out to be, 20 times cosine of 75. So go to the calculator, 20 times the cosine of 75. And I get 5.18 feet. So the base of the ladder is going to be just over 5 feet away from the wall. Let's make sure that's right. And there it is. Number 6. So this one we're actually going to find an angle. We also have a ladder up against the wall, so we can do kind of the same diagram. Here's the ground, here's the wall, here's the ladder leaning up against the wall. Of course, it's a right triangle. The ladder is 25 feet long, and it needs to reach up 20 feet. So the height of the triangle needs to be 20 feet. What should the angle off vertical be? Now, angle off vertical is this angle up here, unlike the last problem where it was the angle off the ground. This is the angle off vertical. So what do we have here? We've got a hypotenuse, and then this side is touching theta, which makes it the adjacent. Hypotenuse and adjacent is cosine. Cosine of theta equals adjacent over hypotenuse. So cosine of theta equals 20 over 25. Why did I leave a little space right there? Hopefully you know. It's because in my next step, I need to do the inverse cosine of each side to cancel out cosine. So theta equals this. Just go to your calculator. So function inverse cosine 20 over 25, and I get approximately 30, oops, don't want to write that in highlighter, 36.87 degrees. Number 6 should be 36.87 degrees, and indeed it is. So do you feel like you know what's going on here? Every problem you're going to end up drawing a triangle. Look, before I even read this, I'm sure that I can just draw a right triangle generic, of course. I'm not drawing it to scale or anything, but there we go. Oops, make that look more like a box. Now I'll actually read the problem. John wants to measure the height of a tree. Okay, so the height of the tree is right here. There's my tree. Could you make it look like a tree? Happy little tree, Bob Ross? Yeah, go ahead if you want to. I can't obviously make it look like a tree, so I'm not even going to try. He walks exactly 100 feet from the base of the tree. So this distance here is 100 feet. The angle from the ground to the top of the tree is 33 degrees. How tall is the tree? All right, we can do this. We've got opposite and adjacent. Opposite and adjacent is tangent. Tangent of theta equals opposite over adjacent. So plug in the numbers. Tan 33 equals x over 100. Can you solve for x? Yep. Multiply both sides by 100 to cancel that out. Multiply this side by 100. X is going to equal this. Let's use a calculator. 100 times the nope, not inverse tangent, so that would have been a problem, times the tangent of 33. And I get 60, nope, not the highlighter, 64.94, what is it, feet again? Yes, feet. Let me circle that and check 64.94. Indeed it is. Number 10. Kelly is flying a kite to which the angle of elevation is 70 degrees. The string on the kite is 65 meters long. Oh, look, we're going in the metric system. All right. So here, I'll draw the triangle a little different. And I'll illustrate. Yay, my illustration skills. Here's the person flying the kite. Now, this is a situation where reality and word problems are going to have to sort of vary or differ a little bit. Normally, you would fly the kite from your hand, but they want us to talk about above ground, and they don't tell us how tall he is or how high the kid's hand is from the ground. So we're going to have to just say, even though it's not really this way, we're going to fly the kite from the ground instead of from this Kelly's hand, which would be more realistic. Whatever, we'll get over it. Okay, so the kite string is 65 meters long, and the angle of elevation is 70 degrees. How far is the kite above ground? So we're looking for that side right there. So what we're looking for, we would call the opposite, and what we're given is the hypotenuse. Opposite and hypotenuse is sine. Sine of theta equals opposite over hypotenuse. So plug everything in. Sine of 70 equals x over 65. Got that? Put the 70 for theta, the 65 for hypotenuse. X is my opposite. Multiply both sides by 65. Cancel that out. X equals this. Use a calculator. 65 times the sine of 70. And I get 61.08. What's my problem? Use the marker, not the highlighter. 61.08 meters. We'll use m for meters. And there it is. All right, one last problem, and we will be good to go. From an observation tower on a beach, a man sights a whale in difficulty. The angle of depression of the whale is 7 degrees. How far is the whale from the shoreline? So here's my tower. The base of the tower is the beach. Here's the ocean. Out here is the whale. The guy's line of sight looks like this. The observation tower, 200 feet. The angle of depression is 7 degrees, which means the angle of elevation would also be 7 degrees. Don't even really need this in the drawing if you don't want it, if it's just distracting. And we're trying to find out how far is the whale from the shore. Again, we could ask how far is the whale from the man. That would be this side up here. And I think, again, I've said this, there's a word problem where you do calculate that, but this time we are going to the shore. So what do we have here? Across from here is the opposite. Touching the angle is the adjacent. The hypotenuse is irrelevant in this problem. Which trig function has opposite and adjacent? That would be tangent. tangent equals, oh, sorry, tangent of theta equals opposite over adjacent. So let's plug everything in. Tangent of 7 equals 200 over x. To solve this, I would have to multiply both sides by x to cancel that out. I get x tan 7 equals 200. Now I've run out of room to work, so I am going to duplicate this and bring it up here. Now divide both sides by tan 7 to cancel that out. X equals this. Let's use the calculator. 200 divided by tangent of 7, 1,628.87, what, feet? Yes, feet. Check the answer, and indeed there it is. So please do the evens. Draw some sort of a diagram. It does not have to be great. Your building doesn't have to look like a building. Your ladder doesn't have to look like a ladder. Your tree doesn't have to look like a tree. But if you want to get fancy and draw the kid and draw the kite with the tail and everything and make it look groovy, then by all means do it. Just don't kill yourself in the details. Do your work, check your work, show whatever work you need to show, and please contact me if you have any other questions. Otherwise, I'll talk to you again.